Hello, algebra students. Today we're going to be learning about how to factor trinomials. This way we're able to rewrite the expression as a product of its factors. You'll know you'll be able to do it correctly when you can write the factors that multiply to x squared plus 3x plus 2. All right, so basically what this lesson is going to be entailing is we're actually going to be going from the answer, or like the x squared plus whatever that we did when we were multiplying, back up to the two terms that we actually multiplied by. So we're going to explore some patterns first. I'm actually just going to grab these two. I'm not going to do all of these. So we're going to look at when you multiply some patterns that we notice. So we're going to first review just multiplying. So remember multiplying with the area model. We did the length times width, so x plus 2 and x plus 1. That's x squared, 2x, 1x, or just x and 2. And then we added everything up and we got x squared plus, we combined our like terms, 3x plus 2. So that was kind of what we did. We multiplied length times width, multiplied, and then added them up. All right, so the same thing with this one. So we're going to do, okay, you know what, we're just going to go ahead and do this one too. Sorry, it just helps. All right, so then this would be y plus 4, and it doesn't matter which one you put on the length and the width. And then 4y minus 2y, and then negative 8. And then we add all of them up, we get y squared. Remember when you're adding integers together, that's going to be plus 2y and then minus 8. All right, and so the last one, we'll just do a little quickly. 3x plus 3 and then x plus 2. That would be 3x squared, 3x, 6x, and 6. And when we add them all together, we get 3x squared plus 9x plus 6. So something that's interesting about this is, again, we're going to be given this actually, and then we're going to have to go back to that. So it helps to kind of notice some patterns within your area model because we're going to use that same box to help us factor in this lesson. So a couple of patterns you might notice, like hello, all of these parts are up in that top left corner. Okay, so that's the first thing you want to notice is like they're all located there, right? That's so nice. So you always know where to put those, top left. The next part is that all of these, just the single numbers at the end, they're all located in the bottom right. So there they are. So we're always going to place that first term in the top left and that last term in the bottom right. Or the x squared in the top left and then whatever the constant is in the bottom right. The tricky part is where is this coming from here, right? Because there's not like a designated. We have two boxes left and only one term. So, well, the 3x is coming from, if you add these together, right? That's where it's coming from when I add them together. Well, that's great, right? You're right, 2x plus 1x is 3x. 6x and 3x is 9x. But there has to be another thing. We have to know, what are we putting in this box? Like, am I going to do like, what two numbers are going to add to 3x? I have to know how to populate that. And so if you're looking at it as it stands, you can think of other things that add to 3x, right? Well, there's 3x and 0x, right? That also adds to 3x. There is, you could do negatives, right? So you could do 4x and negative 1x. That adds to 3x. So the same thing with 9x. 3 and 6 is 9, but so is 5 and 4. So is 8 and 1. So is 7 and 2. So is 11 and negative 2. All of those are going to add to a positive 9. The same thing with the 2y, right? 4y and negative 2y, but yeah, it could be a lot of other things. So there has to be some other piece of information that's going to tell us what number should we put in those boxes. And that other piece is going to be crazy, okay? You're like, oh my God, what a crazy pattern. Well, maybe that's just me because I love math. But if you look here, these two terms here, if I were to multiply them together, 1x and 2x would be 2x squared. And then if I multiply the other two terms, right? The pink and the yellow term, that's going to also be 2x squared. I know. And that's like underneath my hand. There we go. The same thing if I looked at it here. So let's say, well, I multiply these together. So it's going to be 18x squared. And if I multiply those together, it's also going to be 18x squared. It's crazy. Then, if I look at these two here, those two y's, that's going to be negative 8y squared. And if I multiply these together, that's also negative 8y squared. So there's kind of two things about how to fill in that interior box, and we're going to practice this a lot in this video. The first thing is they have to add to whatever the middle term is. Right? Those two green boxes need to add to the 3x. The other thing is they need to multiply to whatever the other side multiplied to. So if the other side multiplied to 2x squared, then they also have to multiply to that. We are gonna, and so that's kind of the 2 points. They have to add to the middle term, and they have to multiply to the opposite corners. I don't know what you call it, like diagonals. The diagonals have to multiply. That would be the right word. This is the same exact slide, but just to add it in for my muffins, you want to draw that in your notebook. So make sure you do that. Okay. So this is a graphic organizer, a little template that we use a lot when we're factoring, and it just kind of helps us keep our numbers organized because we're always going to be looking for two things. We're going to be looking for something that multiplies to something and the same two numbers that add to something else. So let's just think for a second. I want two numbers that when I multiply them together I get 6, when I add them together I get 5. So hopefully you're thinking, ooh, 3 and 2, right? Add to 5, multiply to 6. All right, this one's a little trickier. It multiplies to 20, so things that multiply to 20. Let's see, 1 and 20, right? 2 and 10, 4 and 5. That's pretty much it, right? I don't know if there's like brain. Okay, so, but none of them are going to add to a negative. So in this case, we know when I multiply two negatives, I get positive. So I can do negative 2 and negative 10. See, those multiply to get a positive, but they add to get a negative 12. Okay, and then what about this? Multiply to negative 54. So let's see, negative 54, you could do like, usually, right, 9 and 6. So that multiplies to a positive 54. So let's say, all right, let's say negative 9 and positive 6. When I multiply them, I get negative 54. But when I add them, I get negative 3. So we want to get a positive 3. So you're just going to rewrite it. So this would be a 9 and a negative 6 so that you get a positive 3. That's kind of the same examples out there. Okay, now, it's a lot of steps for these. And I'm going to go through it with you. I wish I would have moved that up a little bit. That's okay. I'm going to go through it with you really slow. But it's going to take a couple examples, to get better at this. So the first thing you're always going to want to do, kind of referring back to last week's lesson, is if there's anything you can initially divide out from each term, do that. That can take care of a lot, actually, and make this a really quick process. In this case, 2, 7, and 3, nothing is besides 1. You can divide evenly. They don't have any like extra variable you can take out because the 3 doesn't have an x. Okay, so that part's done. It's a lot of steps. 7, that's a lot. It's like the most steps of anything we've done this year. All right, the next thing you want to do is you want to draw a rectangle and you want to fill in your ax term. So let's see, let me just highlight. We'll just stick to yellow for that. So your ax term is always going to go in the top left, and your c term, so I didn't really talk about that very much. Now I'm going to go scoot back up here, but this is just the general format for this. So the ax squared, that just means a is always the coefficient of whatever the squared variable is. The b is always the coefficient of whatever the x to the first power is, and the c is always referring to the constant. So that's kind of where the language is coming in from down here. Okay, so the first term always in the top left. The last term is always going to go in the bottom right. Okay, so that's the easy part. We're just going to fill it in. So 2x squared and then the 3. All right, the middle term is going to add to, these two terms are the one that we have to come up with, and we can use that template to help us. We want something that is going to add together to the bx term. So we want something that when I add them together, I get 7x. So that's how I'm going to fill my template out. So it's going to add to 7x. I can even leave it in red here. They need to, it looks bad, sorry. All right, they need two terms that are going to add to 7x, and they're going to multiply to ax squared. So what that means is we know it's going to have to add to this middle term here, but we want them to multiply to whatever this multiplies to. And again, this is going to seem a lot, but we'll do over a couple. Hopefully you'll be feeling a bit better about it. So if I multiply those two corners together, because remember, just kind of flipping back, I know it's probably making you dizzy, I'm sorry, is that these two terms, those diagonal products, were equal to one another. So the way you can figure out what that multiplication part of this is, there we go, is if you multiply those two terms you just filled in. All right, so if I multiply those together, I'm going to get 6x squared. Okay, so we're starting. All right, so you need to think. Two terms. They're both going to have x's in them because we're adding to 7x and you're multiplying to 6x squared. So two terms, add to 7, multiply to 6. So hopefully you're able to think, oh yeah, 6x and 1x. If I multiply them, I get 6x squared. If I add them, I get 7x. All right, good news. We finally finished step 3. Now we're going to fill in these two terms here into our area model here. So they're going to go in here and here. And so that's going to be, we can fill them in either spot, 6x and 1x, or you can switch it. It can be the other way around. All right, we did that. Boom. All right, now we're going to pull up the GCF. So we're going to, and I'll show you what that looks like here in just a second. I kind of want to erase this part right here. There we go. So I'm going to pull in. So before I do that, I'm going to look at my model just one more time. I'm going to do a quick glance. I'm going to make sure it looks right. All right, if I put these together, that's going to be 7x. That's a quick check. If I multiply that, I get 6x squared, which is the same as if I multiply that. So there's another check. So we always want to do a quick check before you start doing the step 5. So what this means, pull up the GCF, is you're going to look at these two terms here, 2x squared and 1x, and say, what can I divide both of those terms by? 1 and also x. So that's what's going to go up here as a 1x. I'm just going to kind of squeeze it. All right, then I'm going to do the same thing with this column. 6x and 3, I can divide both of those by 3. So that's what's going to go up there. Okay, this is looking kind of good. All right, so then, I don't want to do that. I want to get rid of that part. So then what I want to do for the last part is I want to figure out what number would have to be on the side of this rectangle that I would get 2x squared in that yellow box. So 1x times what gives you 2x squared? So that would be 2x. So 1x and 2x is 2x squared. And you can actually do a quick check because then I can take my 2x and multiply it here and I get 6x. So that's perfect. Okay, let me leave it there, 2x. All right, and then down at the bottom, we'll do the same thing. So what can I take? Let me just kind of orange this here. This times what gives you 1x. So 1x times what gives you 1x. And hopefully you go, oh yeah, it's 3. And again, it should work for that bottom right box too. So 1 times 3 is 3. All right, so the last thing is going to be that you're just going to rewrite them as factors. So I can do either 2x plus 1 times 1x or just x plus 3, or you can write it the other way too. It doesn't really matter. And that would be your final answer. It's a lot. This video is very long. Okay, let's do hopefully 2 more, and then we can, we'll practice this over the next couple of weeks. Okay, so we're gonna do the same thing. We're gonna first look for a GCF. What can I divide all of them by? This one does have a GCF. All of our numbers are even, therefore they're all divisible by 2. So the first thing is I'm gonna divide everything by 2. So that's gonna be 4x squared plus 5x plus 1. Okay, now, if there is a GCF, we're actually only going to use, I'll just use orange. We're only going to use this to put in our area model box. So I'm going to do this and like copy it, sorry. And then, no, I didn't like that. One more time, sorry. So I'm going to take this and then, oh, I can paste it down here. Okay, so this is actually what's going to go in the box, whatever's on the inside. And so we're going to set it up the same way. All right, so let me try to color code all this out. All right, so this is going to go in here. Remember, the first term is always going to go into the top left. The last term is always going to go into the bottom right. All right, so 4x squared and 1. All right, that's the easy part. Yeah, plug that in. All right, see, look, we already did this. Whoop, whoop. Okay, now the trickier part, which is that this 5x, we got to figure out, well, what are we going to put in this box? We know it has to add to 5x, but it's got to multiply to what this multiplies to. Whoops. And when I multiply those two numbers together, I get 4x squared. So I got to think of two terms that when I multiply it, I get 4x squared, and when I add it, I get 5x. And this is actually very similar to the last one because it's just 4x and 1x. And sometimes you have to think about what numbers can I multiply to get 4? 2 and 2, 4 and 1, right? 2 and 2 does not add to 5. So 4 and 1, it adds to get 5x and multiplies to get 4x squared. So 4x and 1x. And again, it doesn't matter which ones you put where, but these two terms are the ones that we fill in here. And again, you can do a quick check. They definitely add to 5x, which is good. That's our middle term. And if I multiply this, I get 4x squared. If I multiply that, I also get 4x squared. Okay, I'll just like do this. All right, so that being said, then you're going to pull your GCF up. So 4x squared and x is going to be, the only thing both 4x squared and 1x have in common is x. The same thing, we're going to look at the GCF here. Both of them, the only thing they can be both divided by is 1. Then we look at this side. So what do I have to multiply x by to get 4x squared? 4x. 4x times x is 4x squared. You kind of have to like make, it's almost like a puzzle. You got to make it work. 4x times 1 is also 4x, so it's perfect. And then the bottom left, what times x gives you 1x? 1. And the same thing, 1 times 1 is 1. So you can do 100 checks as you're doing this along. Okay, so that's good. We filled in the model, we pulled up the GCF, and we found the length and width. Now, last thing we want to do is we want to write them in parentheses. Something that's really important is if you have a greatest common factor, which we do in this case, that's like, never mind. If you have a greatest common factor, like we do in this case, you want to make sure that you also bring this down here. So in your final answer, the GCF has to float outside. Oh my God. Okay. All right, last one I'm doing with you. And then for real, I'm done for this week. I'll save the other ones for next week. All right, so we're going to look for a factor GCF. There is none, right? No factor, no GCF, because that is a 1. We're going to go ahead and fill it in. So I'm just going to, oops, we'll stick to the same colors. That's going there. It's going there. And then let's see. These two, we don't know that yet. Okay. So then that's going to be x squared and negative 24. So we want something that's going to add to the middle term. So it's going to, these are going to add to 10x. Maybe I should use blue. There we go. No red. Oop. All right. So it's to add to 10x. And it's going to multiply to this, so multiply to that, so that's going to be negative 24x squared. All right, so we want to think of things that multiply to negative 24. 2 and negative 12, right? 3 and negative 8, negative 3, and you can kind of switch the signs around because only one of the numbers is negative, so that adds to 5 and negative 5. This is pretty close. That adds to negative 10. So if you switch the signs around and you do negative 2 and 12, you're going to get to a positive. So those are going to be our numbers there. Let me do them. I'm just doing green. Okay. So it's going to be 12x and negative 2x. So that is what we are going to use to fill in 12x and negative 2x. And then again, we're going to pull up the GCF. So let me erase this part. So in these two, we have an x in common. And these two here, both of those numbers are divisible by 12. You always want to take the greatest common factor. They're both divisible by 2 and 6, but they're both divisible by 12. All right, and again, you're going to fill the side in. So x times x is x squared, x times that. Okay, that's good. All right, and then what times x is going to give us negative 2x? That's going to be a negative 2x squared. All right, so that would be our last step. So x plus 12 and then x minus 2. Oops. All right, don't worry, muffins. It's a lot, but hopefully this is a great intro to it. We're going to do a lot of practice in class, and we're going to do this next week as well. So we're going to spend a lot of time on factoring. It's super important. But thank you so much for watching, and have a great day.